Okay, so this is lesson number 4, simplifying radicals, specifically numerical radicals. So the next ones we're going to go to our algebraic. So all we're dealing with today are numbers. We're just going to process numbers. Okay, I know you can do this on your calculator, but I don't want you to do it on your calculator because you need to be able to process numbers without your calculator and understand the concept. So students will simplify numerical radical expressions. So we talked about radicals yesterday. We talked about the index. You should already know what the index is, which is this number here. This is your index. What number do we assume is there when there is no number there? 2, good. So we call that square root. And then this number right here is called the radicand in the middle. Okay? Sorry, that's really messy, but that's just so you see that. Okay? Here are the steps for the day. Identify the radicand and index. Factor the radicand and identify any roots and simplify. So we're going to go back to even like 6th grade math. When we say factor the radicand, I'm going to have you make factor trees where you start with your factor at the top. Let's say your number was 100 and you're just going to break it down. You're like, oh, that's like 4 times 25 and this is just like 2 times 2. And then when you ever get a prime number and you circle it and you keep going on the other ones. So and it doesn't matter which order you go, you get the prime factorization. So I know 100 is 2 times 2 times 5 times 5. Okay? This is just stuff you should know already. I'm just trying to remind you, okay? Here we go. Numbers 1 and 2. So just watch up here. The way I teach square roots is the following, okay? I like thinking of it as a prison. So you got numbers in the prison. Whenever you see the square root or the radical sign, it's like a prison for numbers, and they're trying to break out. So the way prisoners break out is they have to look at the index on the prison. So on number 1, we know that it's an index of 2 because there's nothing there. So we're assuming it's a 2. So I'm going to put it up there just for now. So we're trying to find 2 numbers that could pair up inside the prison that could break out. So I know my multiplication tables really well. I know that the 2 numbers are going to be 6 times 6, right? So 6 and 6 try to pair up, so I'm going to rewrite this. Let's say the prison was 36, but it's really, if you look deep inside the prison, it's just 2 numbers that are 6 times 6. So these 2 6s try to make it out. So they pair up together. They get out of prison, but the prison guard shoots one, doesn't make it. The other guy makes it out. And if there's no one left in the prison disappears. So that's your answer, 6. Remember yesterday what other 2 numbers could be multiplied together, or what other number could be multiplied together twice to be equal to 36? Negative 6. So really you have 2 answers here that are possible, 6 or negative 6. Okay? Does that make sense? Raise your hand if you remember my prison story from 2 years ago. Okay? Algebra 1. Good. Alright, so that's the same concept. That's what we're doing. Watch me do number 2 one more time. Number 2, we have the square root of 80. I know that it has an index of 80, so I'm trying to find 2 numbers that could be multiplied, or one number that could be multiplied by itself to be released from the prison. So I'm going to do prime factorization. 80 I know is just like saying, I think 16 times 5. Let's just do 4 times 20. Just make it easy. Doesn't matter what order you go. And I know 4 we could leave, but I know 20 is like saying 4 times 5. Actually, what was it? Okay. So 80 is like saying 4 times 4 times 5, and I'm trying to find 2 numbers that I can multiply together. So I'm going to take the square root of 80 and rewrite it as 4 times 4 times 5. Okay. In this example, it's the prison, so we're trying to ask ourselves what 2 of the same numbers can pair up together to break out of this prison. These 2 4s try to make a plan. They're like, let's get out of here. Let's leave 5 behind. What a loner. So if they break out. One of the 4s gets killed. One of the 4s makes it outside. The 5 is left on the inside because he was by himself. So that's your answer. 4 rad 5. Okay. When you look at radicals, you have to simplify them, okay? This is a form of simplification. So if you see a number like this and you could simplify it, you have to finish it, okay? Just like yesterday, remember when we had or a couple days ago, we had that last problem. It was like fourth root of 2 all to the 8th power, and then you found the answer to be 2 rad 2. Or no, yeah, 2 to the second power, and then I told you need to simplify even to 4. So, anyways, that's how you do numbers 1 and 2. Questions? All right, good. So let's have 2s today talk first. Why don't you 2s are talking about number 1 first, and then 1s will talk about number 2. Ready, set, talk. What is the square root of 32? That's what we're asking ourselves right now. The whole prime factorization. Start with 32. And you know this is like saying 4 times 8. 4 is like saying 2 times 2. These are now prime, so circle prime numbers. And just leave it there, okay? 8 is like saying 4 times 2. 2 is prime again. And then 4 is like saying 2 times 2, okay? If you're having trouble, do the prime factorization. Watch the trick here. Then you go, bring your problem down. I'll bring it down here because I ran out of space here. You're going to go the square root of, how many 2's do I have there that are equal to 32? 5. So we got 2 times 2 times 2 times 2 times 2. Okay? What's the index? Look at the index here. It's a 2, right? So we're trying to find numbers that are the same that are in pairs. 2 and these two 2's, right? This first pair tries to break out. One of them doesn't make it. One of them does make it out. This second pair of 2's, one of them makes it out. The other one doesn't. So the second one has one that makes it out. This last 2, does he have a partner to try to break out of prison? No, so he's stuck in prison. So now we're going to rewrite this. What's 2 times 2? 4. So your answer is 4 rad 2. Okay? Okay, that's the easiest way. That's the foolproof way. It's longer, but it works. Now you could have done 16 times 2. What's the square root of 16? So you would have just done 4 rad 2 from there. Does that make sense? Once you get good at this, you're going to be like, oh, I don't need to do the whole factor tree. I just know that it's going to be 4 rad 2. Yep.
Yeah, like then you just leave it like 4 and then 8 keeps 2 figures.
You could have done 16 times 2, and then, which is 4 times 4. Oh, yeah, you could have done that too. Yeah. Are you trying to say here?
Yeah,
at this point? Yeah.
Just bring down the 4 and then 4 times 2.
Yep, that's a good question. She's all like, couldn't you do 4 times 8, and then you know that 8 is 4 times 2? So you had 4 times 4 times 2. Yep, same thing. Okay, but this, I want you to know, like, if you ever don't feel good about multiplying, then you need to make the factor tree. Okay, number 4, ready, set, go. All right, so again, 128 I know is like saying 2. Whenever the numbers are big and they freak you out, don't worry. This is even, so 2 must go into it. 2 times what is equal to 128?
64.
Good. Oh, 64. That's like a magic number to me. What is 64 equal to? 8 times 8, right? So you don't have to break it down to the smallest amount. You're like, oh, these are like, I could take these and pair them up, and then this guy's alone, so because it's already prime. So I'm just going to rewrite this as 8 times 8 times 2, right? Because that's what it is. I don't have to go down to 2 times 2 times 2 times 2 times 2 times 2, right? We don't need to do that. So we're going to take these 2 8s. They're trying to break out of prison. Only one makes it out, so we got 8 making it out. The other 2 is stuck in there, so your answer is 8 rad 2. Yep.
So like the answers vary?
The answers?
Yeah.
No, you always have the right answer. It's just the way you get to the answer varies. So your factor trees could look totally different. Yours could look totally different from his and everyone's. It all depends, but they always lead to the same answer if you do it correctly. Okay? So, here we go. Next one. Let's get some more practicing. This one's a little harder now. We're trying to find 3 numbers that multiply to 256. 3 numbers that multiply to 256, right? Or 3 numbers that could be combined with that to be 256. A little bit harder, right? If you want me to help you out, I'll start you off with this. I know 256 is like saying 16 times 16, because I know those are perfect squares. You should memorize your perfect squares up to 25 times 25, by the way. Okay? So I'll start you off with that, so keep going. We're trying to find 3 numbers that are going to multiply up to 256. Look up here, please. And then you could write this down. So on this one, cube root of 256, we're trying to find 3 numbers in the prism that could be the same numbers that could break out, okay? Not 2, but 3. So we know that 256 is 16 times 16, but 16 can't break out. Why can't 16 break out? Because I need 3 16s. But how many 16s are there right now? 2. So that doesn't work. So I'm going to have to break these apart some more. So I know that 16 is just like saying 4 times 4 on each of these, okay? Right? Wouldn't you agree that 256 is equal to 4 times 4 times 4 times 4, right? So I'm predicting that I'm probably going to need to take out these 3 4s, right? So now I'm going to rewrite my problem as the cube root of 4 times 4 times 4 times 4. Right? So I'm going to take 3 4s because in this prism you need to have 3 of the same number to break out of it. Okay? So these 3 4s, it's high security, like we need teamwork, we got to get out of here. At least one of us will make it out alive. So one of the 4s makes it out alive, but the other 2 get shot, they don't make it. This last 4 doesn't make it out because he's like a loner. He's like, man, I didn't get in the crew. So all we're left with is 4 cube root of 4. That's it. And you have to put the cube root there. Some of you were really close, some of you were not. Okay, some of you forgot to put the cube root thing. Okay, so why don't you write this one down, because clearly that was more difficult. Just to help you get started, whenever you see a negative here, let's just ignore it for now when we make our factor tree. 625 has what number at the end? 5. So what number do you know for sure goes in there? But it also has a 2 in front of the 5, so what number do you know goes in there? 25. Does that make sense? So you need to look at those tricks to factor. 25 times 25. But we need to have, what's our index here? 3. So we need to have 3 of the same number to break out. So this is like saying 5 times 5 times 5 times 5. Now, I'm just dealing with positives here, right? But what's a radicand? Negative. So let's think about it. Let's pretend this was all just negative 625. So I know this is just like saying this times that, right? You agree? And negative 625 is like saying that, right? But couldn't I say that this is also equal to negative 25 is equal to negative 5 times positive 5, right? Do you agree? And wouldn't this 25, couldn't this be equal to negative 5 times negative 5? Y'all see that? So really you need to take out the negative. If it's a negative radicand with an odd index, negative radicand, odd index, you need to take out, you need to assume it's negative 5 times negative 5 times negative 5 times 5, cube root of this. 3 negative 5s try to make it out. Only 1 makes it out. So you're going to have to take out that negative 5 or simplify it and leave the positive 1 on the inside. Okay? That's just the only thing I'm going to clean up on that. Oh yeah, you need the cube root. Thank you. The index has to be there. Thank you so much. Has to be there. Otherwise it's wrong. Okay? Does that make sense? Okay? Okay, that was the last example. Any questions on today's lesson? If you get through this, then homework should be a cinch, okay? So, let's turn off our iPads, go to the Desari and close the one you're working on and delete the one that you just worked on, and then flip it off for a moment. And I'd like you to discuss these 4 questions. Ready, set,